Hello guys, today we're going to be looking at non-standard methods for the subtraction of fractions. Okay, so fractions, they are not fun numbers to look at. They're not whole, they're not clear and cut for us. So it can be very intimidating to work with fractions, especially when you're subtracting utilizing fractions. This is even harder when the fractions you're working with do not have the same denominator, or what we would call the common denominator. So before we get into the non-standard methods, I want to show you guys what the standard method would look like when subtracting fractions. So we're going to move ahead and we're going to look at this problem here, 2/3 minus 1/2. In order to find out what the common denominator is, we can utilize the product of the denominators so that we can find the common denominators. So the denominators of 2/3 minus 1/2, that is the 3 and the 2. The product of 3 and the 2 is 6. So 6 is our common denominator. In the second area here, we are looking at what we need to multiply our fractions by in order to get the common denominator. So the denominator of 3, you need to multiply it by 2 in order to get the common denominator of 6. The denominator of 2, you need to multiply it by 3 to get the common denominator of 6. But we don't just do it for the denominator, we have to do it for the numerator as well, or what we would look at as a multiplying by 1, because 2/2 and 3/3. So this does not change our numbers that we're working with. It just moves them to a unsimplified form to help us with the subtraction. So 2/3 times 2/2, that is 4/6. 1/2 times 3/3, that is 3/6. So we keep our denominator here, the 6, but we look at the numerators and we do the subtraction for those. The 4 minus 3 is 1, therefore our answer is 1/6. Okay? We're going to look at this same problem, but we're going to utilize a non-standard method to solve. So what we're going to do is we are going to use pattern blocks. Okay? Before we move down to that area, let's just look at the pattern blocks. Here, the pattern blocks, we have a, I believe this is a one. Well, we have this shape here. I am drawing a blank as to whether it's a hexagon or a pentagon, but regardless, the point is that that is the one whole. Okay? There are other shapes like the triangle, the trapezoid, and the rhombus here that when you put several of them together, you can get this one whole. In order to get the one whole utilizing a triangle, you need 6 triangles. Therefore, one of these triangles is 1/6 of the whole. Okay? Looking at the trapezoid, the same idea. Here we need 2 trapezoids to make the one whole. Therefore, the one trapezoid is 1/2 of the whole. And the same thing for the rhombus. We need 3 of them in order to make the one whole, but just one of them is equal to the 1/3. Alrighty, so we're going to utilize this idea and these visuals to help us solve this 2/3 minus 1/2. Okay, so once again, we know that the whole yellow shape is equal to 1, and we want to do 2/3 minus 1/2. Okay, so the 2/3 of the whole looks like 2 rhombuses put together. That is 2/3. Okay, the 1/2 is just the one trapezoid, so that is the 1/2. In order to show the subtraction, we are going to place the trapezoid on top of our 2/3. So we're going to place the 1/2 on top of the 2/3 in order to take away the 1/2. Okay, the way that this fits perfectly, utilizing the way that our shapes are formatted, we place the 1/2 on top of the 2/3, and this red area covered by the 1/2 or the trapezoid, it's gone now. We do not have that area anymore because we have taken away the 1/2. What we do have left is this little area of the rhombus. And when we look down here, we can see that one triangle is equivalent to the area that is left over of the rhombus. So 1 triangle is equal to 1/6, and that is our answer, guys. And we know that this answer is correct because when we look back to our standard method, that was the answer, 1/6. And we know that the 1 triangle is equal to 1/6 because we can look back at our shapes here and we see the triangle is 1/6. Okay, moving forward, we're going to look at another non-standard method to solve. This time we're going to use a number line. So here our problem is 4/5 minus 3/10. We're going to draw a number line that goes from 0 to 1. Remember that 5/5 or 10/10, that would be equal to 1. Okay, for the 4/5, we want to cut our number line into fifths to show the 4/5. 1, 2, 3. Okay, sorry guys. So here we have 1/5, 2/5, 3/5, and 4/5. Okay. And then the 1 is the 5/5. To show our 4/5, we're going to color into or draw another number line to show the section that is the 4/5. From the 4/5, we want to take away 3/10 of it. So from this green area, we want to take away 3/10, but we cannot see that right now because we only see the denominator of 5, and we need a denominator of 10. So we are going to cut this number line up again. We're going to cut each fifth in half to get our tenths. So 1/10, 2/10, 3/10. We're going to go all the way until we get to 9/10 because 10/10 is the 1. Okay, so here is, here is our 9/10. Okay, we're going to take away 3 of those, we're going to take away 3/10 from our 4/5. So remember, this area here, this green area, that is our 4/5. And we want to take away 3/10 from that. And we see here, this is our 3/10. So to take away our 3/10, we have to take away all this area here from our number line. We don't have that anymore. It's gone because we've subtracted it. What we have left now is this yellow area. When we look at the tenths side of our number line, we can see that this is 1/10, 2/10, 3/10, 4/10, and 5/10, which is our answer. Okay, we took the whole 4/5, we subtracted our 3/10 area, and we were left with this area over here, which is the 5/10, our answer. Alrighty guys, so those are 2 non-standard methods that we can utilize in order to solve the subtraction of fractions.